Hey everyone, welcome to the sixth and final video in the new team's Onshape introduction series. In this video, I'll be running you guys through a couple of unconventional sides of CAD that can be really powerful and probably extremely necessary for our applications. The first tool is FeatureScripts. FeatureScripts are essentially custom tools that can achieve things that we can't, or significantly expedite and robustify our models. On the Onshape cheat sheet, I've provided a small list of learning materials for FeatureScripts as well as some recommended examples. So if we have a look down here, we've got all the documentation that Onshape provides as well as some tutorials and stuff. But the first place I recommend having a look at is the Onshape recommended FeatureScripts. So if we have a look at them, so we've got things like the Beams FeatureScript, which is very similar to the advanced framework tool in Creo. It can let you really easily create chassis and suspension tube geometry. We've also got tools for creating custom wiring, aerofoil profiles, and gears as well. The list continues down here. We've got things like the point pattern, which works the same as it does in Creo. 3D print, infill things, belt generators. There's quite a lot that you can get from the Custom FeatureScript library. So I've provided this list here. I've also got one from someone on GitHub as well that's actually got quite a few. On this sheet, I've also kind of written down the ones that I find most useful. But I really recommend that you guys kind of do your own deep dive and have a look at what other feature scripts are out there that you might find useful. But the feature script that is really important for everyone to know about and use is the parameters feature script, which is just up here. So if you navigate to the new team's template document folder, just in there, and then open up this document here. So this is what the back end of a feature script looks like. So typically you guys would never have to deal with any code or anything like that. This is kind of just what drives the tool that you end up using, which will typically look the exact same as the Extrude tool or the Revolve tool or anything like that. So this parameters feature script allows you to define variables in the script which you can then use in any part studio that you want. This is to address the fact that variables that you define in a part studio only exist within that specific part studio. Sometimes you'll need to have parameters like 3D print wall thickness or suspension tube diameter, which need to be accessed from different part studios. I showed this in an earlier video, but I've since cleaned the code up significantly. The massive benefit of using this approach is that you only need to update your parameters in the feature script, and then all of your parts will update automatically. So I've got two example parameters down here, example 1 and example 2, and I can reference these in any part studio within the document. And you can use these parameters pretty much anywhere where you're able to input a number. So you can use these for sketch dimensions, extrude depths, pattern instance counts and spacings, the list goes on. And you're also able to perform mathematical operations on your parameters, which is what I've done down here for examples 3 and 4. So you can see that in these examples, I actually refer to other parameters that I've set as well. So this is actually a really important tool because relying on you or the next person or the person after that to remember to update every instance of a certain parameter across different part studios is really poor CAD and really weak design intent. It's much better to basically just set it once, and then everywhere where you're using that specific variable, you just reference the one that you set in the feature script. And just to show you guys my application of it, this is obviously the accumulator assembly. I've got my parameters feature script just down here, and here are all of the parameters that I've set to kind of be global variables throughout the entire part studio. And I do a couple of mathematical operations on them as well. Alright, so now a very quick demonstration on how to use the parameters feature script in your own part studios. So I'm going to create a blank document. Now that that's loaded, I'll create an empty feature studio. So this is for the moment just going to be a blank feature script. Once that's in there, I'll go back to the new team's template document and I'll copy and paste all of the code from there into my blank one in here. The next thing I'm going to do is read all of these instructions very carefully. That'll tell me that the next thing I need to do is change the title of this feature studio. So the name of this document is blank and I'll put parameters after that. The next thing that I'm going to do is I'm going to change these variables here to be something else. If I do that, these calculations down here would get broken because they reference those parameters. So all I'm going to do is just delete these lines off the bat. Cool. All right. So now I'm going to change these variables to something else. So I'll call them my first variable, and I'll set that to be 50. And then of course I'm going to give a really good description, which is really important because the next person that comes through this feature script probably won't know exactly what parameters you're using. Hopefully you've given them logical names, but you should always give them a description as well. And then I'll create another variable, and unsurprisingly I'll call it my second variable. We'll set it to be 100. And then we'll give it an even better description. Excellent. All right. So as soon as you've finished making changes to your Feature Studio, either just adding more parameters or changing what the parameters are, all you have to do is hit the commit button up the top there. All right. We'll go back to our Part Studio. And to demonstrate off the bat that we don't actually get access to those parameters straight away, I'll try and use them in this sketch here. So if I type a hashtag, which is the way to access any variables, you can see that there's none in the drop down here. So I'll cancel out of that. So to add the parameters feature script into this Part Studio, I need to use this button up here. And you can see that we've got the blank parameters that we wrote just before. It is possible to access that Feature Studio using this Add Custom Features. This is a little bit different. So whenever you're using one of the off-the-shelf feature scripts, like the gears one or the beams one, you would add it through here. So I can search for beams and it comes up there. And so it is possible to add your own ones even from the current document through this menu. But as soon as you do that, it'll think that you've added it as a linked document. So then every time you add a parameter or change the values of one of your parameters, you'll need to right click and update it in here. And then you'll need to update it in your feature list as well. So it's just really slow and tedious. Whereas if you add it with this button, then as soon as you hit commit in your parts in your Feature Studio, it'll update all of the parameters across all of your Part Studios. So let's add it into our Part Studio there. So you can see it just comes up as a feature there. And as a side note, whenever you download, whenever you use like the beams or any of the other Feature Studios, you, as I said before, you won't really be looking at the code. You will just be looking at sort of this side of things. So this is the simplest menu that you can possibly have. You can tell that it's a lot simpler than things like the Extrude one and everything like that. But for beams and everything else, you'll see a menu similar to this. Anyway, so we've added that parameters feature script in here now. So now if I go to sketch, I'll draw another rectangle, and you can see that when I start typing a hashtag, those variables that I put in popped up straight away. So I'll call that my first variable, and I'll set these two sides to be equal. Fantastic. All right, so that's 50 mils, and we can click on that and see down here that indeed it is. We can change that variable to be let's call it 150. All I have to do is press commit. And then when I go back to my Part Studio, you can see that that's updated automatically without me having to do anything else. Fantastic. So now I'll actually extrude that, and I'll say in the first direction, I want it to be my second variable. Press enter to confirm. And then I'm actually going to do a second end position, and I'll do 0.5 times my second variable. Wonderful. So that's really all there is to it. So now you guys can go through and you can add more features of your own. You can do mathematical operations as well. Please remember to read the instructions up here. It's super important that you do, because there might be some things that you miss. And if you ever want an example on how to use all of this stuff, I recommend that you just go to the New Teams Templates document, because I've obviously, I've done the example 1, example 2, and some mathematical operations on them. And then I've also got a feature script where I have I've got a Part Studio where I've kind of done all this sort of stuff here. So on this sketch, you can see that I've used example 2 and example 1, and I've done the same thing for an extrude there. I've also said to read the comment, because the comment kind of explains what's going on in here. Fantastic. So that covers how to use the parameters FeatureScript within one document. However, sometimes, for example, for EV3, we'll have things living in a lot of different documents, and it might become the case that you'll need to access certain parameters from one of the other documents. So if that's the case, I'll go back into my blank one here. I'll go into my Part Studio. So now is the time where I'll actually use the Add Custom Features button. So I'll now navigate through to the new teams template one, just for another example. So I'll grab that feature script there. Wonderful. So now it says that it's been added to my toolbar. So if I actually wanted to add it to this Part Studio, all I need to do is click on that, and it does the exact same thing as before. And so now you can see if I drag that up above, and I'll change my extrude depth. I'll change the first one to be example 1, example 2, so you can see that the ones from the new teams template document have popped up. Now, if I change what my parameters are in here, so I'll call this 1.2.345, I'll go commit. You'll notice that nothing immediately happens over in this document. I don't get a notification here or here that changes have happened. What I need to do is I need to create a version of the document where the initial feature script is. As soon as that's finished, I can go over to my document where it's been inserted as a linked document, and you can see it pops up on the toolbar here. So if I want to keep inserting this into other Part Studios, I need to update this, because at the moment I can create another Part Studio, and I can still use this, but it'll just be outdated, which is what that kind of blue thing there reflects, and it says it over here as well. So if I try to reference one of the example 1, you can see that it's still 12.34, but if I go into my initial Part Studio, I'll right click and update all. Wonderful. But you'll still notice that in this Part Studio, because this one is still not updated, it's just been updated from my toolbar. If I try to use example 1, it's still hasn't been updated. All I need to do is right click over here and hit update link document. And now I'll have access to that variable after it's been updated. Alright, so the other feature script that I'm going to show you guys today is the point pattern feature script. The only reason that I'm showing this one off is because it's not documented quite as well as ones like the beams and wiring feature scripts are, but it's still very, very useful. So my biggest application for it was in this accumulator top plate. So you can see I've got a bunch of bolt holes everywhere. I've got a whole bunch of M3s and I've got some M4s as well. And every single one of these holes had to have a pocket on the underside that was specific to the bolt location, bolt size, and all of these locations had to be updated parametrically as well. So this is a really good application for the point pattern, and now I'll show you how to use it for yourselves. Alright, so I've jumped across to another Part Studio at the moment. The very first thing that I'm going to do is I'm going to add the point pattern to my toolbar. So I'll search for it in the little search bar up here, and I'll grab the top result. I'll click that to add it into my toolbar, and you can see it's appeared just there. Alright, the next thing I'm going to do is I'll define a bunch of locations that I want things to be patterned at. Obviously you guys will define these a lot more carefully than I have. Alright, now I'll just very quickly do a little bit of modeling just to create some features for us to pattern. Terrific. Alright, so now we've got some features there that I can use the point pattern on. All I'm going to do is I'll use the point pattern button up there, and then I can choose between part, feature, and face. For a couple of minor reasons, I actually recommend using feature instead of face for this particular application. So I'll do feature. It prompts me for what features I want to use. So I'll grab those two extrudes. A reference point, so that's basically saying like what is the point that relates to those features that you've made. So obviously that's that one just there. And then for locations, I can actually just click sketch 2 and it'll grab all of those vertices, and I'll just click apply per instance, and then you have it. So the really good thing about this is I can go back into sketch 2 and I can add even more points. and it grabs all of those and does the same thing. So this is really powerful. If you guys need to use this in an assembly, you can assemble something to one of these features and then use the replicate tool, and it'll jump to all of those as well. Alright, so that's enough chatter about FeatureScripts. Let's talk about configurations, the last topic for these introduction videos. So Onshape has a few really good courses on configurations, which I highly recommend everyone go and watch. I don't classify them as mandatory knowledge to start using Onshape, but they can be extremely useful in heaps of different applications. And if you want to build some seriously advanced models, this is the way to do it. So I won't really get into the weeds of it all, but I'll give a quick rundown and show you some examples. Configurations are how I drive the fasteners document, such that you can insert the fastener assembly at whatever thread diameter and length you need, with or without the nut and washers. The original part studio and assembly don't actually get modified, but each instance of the fastener assembly within my accumulator is just a different configuration, and because it's all driven by configurations, I can change those bolt parameters at any time. There are a few different ways that you can control a configuration in Onshape. The first one that I'll talk about is the variable configuration. So you can change input variables like a bolt diameter, the width of a brake pedal face, or the text that appears on the back of the rear wing, for example. And that's what we're looking at here. So you can see in the example they've set up a configuration variable called wheel width. They've decided that it's going to be a length type of variable, and then here they've set up some default values as well as some extremities. And then from within the part studio, they're actually able to reference that wheel width parameter pretty much in any scenario where you want to input a text or numerical value. You're also not limited to only use one configuration variable in each part studio. So you can see here they've extended it out to include wheel width, wheel diameter, the number of spokes, and you can see the type of things that they're controlling as well. So they're changing some sketch dimensions there, some pattern instance counts, and you can also see up in the top left corner, you can input these values as well to basically kind of see how your part studio reacts to the changes that you're implementing. The second type of configuration option that you can have is a checkbox. So checkboxes, you can use them to change yes or no options, such as having a deep socket on your socket wrench, or saying that certain things are or aren't suppressed, like including or excluding nut and washers from the bolt assembly. And the last type of configuration is a list configuration. So a list configuration can set several specific parameters at once, like chair height, seat width, seat depth, number of leg supports, etc., to a set of predefined values that you control with a table. So you can either enter this table manually, which would be pretty sensible for the case on screen, but you can also create a table in Excel or Google Sheets or something like that and copy that in if you've got lots of configurations. In the fasteners example, I've left it up to the user to select whatever bolt length they want. They can also technically select whatever bolt diameter they want, but I've used a FeatureScript to generate all the bolt dimensions from the thread diameter, and those calculations only work for standard metric sizes from M3 to M24. But you can input any length that you wanted, so you could have an M10 by 4, even though that would never really exist, and that's because I used a configuration variable as I discussed before. If I wanted to, I could create a table of standard sizes, like what Creo's Intelligent Fastener tool and Onshape's standard content library use, which would be a configuration list. However, the issue that I faced with the fastener libraries in Creo and Onshape is that neither of them had every fastener that we use. So then we're forced to use a combination of pre-made fasteners as well as self-modeled ones, which is really gross. So that's why I've controlled the fasteners document with configuration variables instead of a configuration list. Even though a list would be logical because it forces people to use standard bolts that actually exist and can be easily purchased, chances are it wouldn't include every bolt that we use. Plus, I definitely couldn't be bothered to create such a big table of standard sizes. That's an exercise that I'll leave up to the reader. So in the part studios in the fasteners document, I've got a couple of configuration variables that I talked about earlier, the thread diameter and the body length. And so these control obvious things like in the first sketch, that there is going to be set to the thread diameter. My extrude length is going to be set to body length. And so I can change these dynamically in the part studio. Doesn't really matter too much what I do at this level. But then my fastener assembly also uses configuration variables. And then this is where I can basically change the configuration of a part that appears in here. So I can set change configuration there. And so that's where I've actually then used my assembly configuration variables. So I have another configuration variable called thread diameter there, and once again body length as well. And so those are set in the assembly configurations over here. And when I go to change these, I can just reference these variables here, and it basically requests the Part Studio to send me the right size. So that means that when I insert my fastener assembly into another document, it'll ask me what, thread diameter and body length I want. And so that means that I'm changing my assembly configurations are, which then changes what the Part Studio configurations are as well. And then for things like the nut, bolt, and washer, that's just one of the checkboxes down here. And these just decide whether those parts are suppressed or not. Something else that I've included in this fasteners document is the provision for naming. So on your bill of materials, it would be kind of awful if we just had 2,000 parts named bolt. And so I've included a feature script here which changes the part number of the part depending on the configuration variables. So you can see if I change that to be M6 by 30, that reflects there. And it goes the same for nut and washer as well. All of those parts will be renamed depending on the parameters that you use. The very last thing that I'll show you guys is the feature script that I use to control all of the dimensions for each bolt and nut. So obviously for a cap head bolt, the dimension of, like the size of the head, the depth of this hex here, what that hex size is across the flats, all of those things are dictated only by the thread diameter size. I thought it was going to be pretty lousy if I asked you guys to input every single one of those dimensions correctly every time you wanted to use a bolt. So instead, all I've got you to do is put in the thread diameter and then this bit of code over here. It's basically just got a table where it kind of reads from and says, if the bolt is an M4, these are all of the dimensions for all of your nuts and your washers and everything like that. I should also mention that this is far from a clean implementation of this sort of thing in code. So once again, if the reader feels inclined, I'll leave this exercise to you guys to improve if you'd like. Anyway, that's all I've got to talk about for configurations and feature scripts. I hope that this stuff was kind of helpful for you guys. I realize that it's pretty unconventional and pretty unfamiliar from what we're used to. But that marks the end of the new team's Onshape introduction videos. So I hope these were useful to you guys, and I look forward to hearing your feedback. Thanks.